Hello, can anybody hear me? Can anybody hear me? So, so tonight I was just thinking about talking about cutting tools. Cutting tools, what they're used for, which tools are used for what, why the different tools are different, and what works best for what. So, I guess we could just get started. And I'm going to start off. I'm going to start off by just a little bit of introduction about tools. Now, the first thing I can tell you is this: your CNC machine will never be any better than the tools that you are using. I mean, you could have a $50,000 CNC machine, but if you have a $10 tool in it, your machine is not worth anything more than $10. Okay? So, tools are basically the heart of your machine. I keep telling people one thing: never skimp on tools. Okay? I mean, it'd be like, for example, just an example is buying a Ferrari. Okay? And going to Harbor Freight or going somewhere else and buying tires, really cheap tires to put on it. Okay? Same thing. All right? Now, as you all know, there's a lot of different kind of tools. Okay? There are, I mean, you hear up cut, down cut, straight cut, uh, tapered tools, you have ball nose tools, you have V bits or V cutting tools. So each one has their own purpose. All right. Now, on Inventables website, as everybody knows, I can't stress it enough. I cannot stress it enough that you should really, really spend an entire day on Inventables website. Okay? And the reason for that is they have so much information there. It's unbelievable. If you have a 3018, you should have been on Inventables before you even got your machine and learned what they had to offer. Okay? They have videos. It's called Bits 101. It explains exactly, and they even show you examples of which tools to use for which purposes. Okay? Now, I'm going to turn you around here. Okay. I'm going to turn you around there, and I'm going to pull you up a little bit here. Okay. Now, in cutting tools, I'm just going to open up this one window here, which is bit, or what they call bits. I know I try not to call them bits. Nobody else in the CNC world call them bits, but Easel wants to call them bits. So for right now, we'll call them bits. Now, one thing you have to realize, now, I'm going to just turn you back a little bit. Okay? Now, the thing about it, the thing about cutting tools and easel. Now this applies to easel, okay? In that window that I just showed you, where they have all the different cutting tools, okay? They have custom, straight cut, upcut, down cut, all these different tools, okay? And they have pictures of them there and that. Well, guess what? Guess what? Your 3018 could care less. The only, I mean, the only thing that your 3018 needs to know, or it's the only thing it will know, is the exact diameter that you put in. That's it. Whether you choose one of those, tools, those cutting tools that are in the picture here, easel does not, your machine, your 3018, will never know what tool you have in there. The only thing it has to go by is the diameter that you put in there, the size. Okay? I'm serious. Your 3018, you could put a hammer in the spindle and it would not care. It would think it was a tool. Okay? So upcuts, down cuts, straight cuts, all those, it's you that needs to know what they're being used for and how to use them. Nobody's going to tell you. I mean, your machine is not going to tell you. Easel is not going to tell you. Okay, so that is why you have to know beforehand. I mean, when you're gonna be making a project, first of all, you find your piece of wood. Okay, your material. Now, once you have found your material, then you can start thinking about what tool am I going to use to cut this material. Okay, so for example, let me grab some different materials here. If I was cutting on plywood, thin plywood, okay, or plywood period, I would use a down cut. A down cut. Now, what's the difference? What's the difference between an upcut and a down cut? An upcut and a down cut. Well, let me show you. Let me see if I can get this in here. Now, watch as I turn this tool clockwise. Look at those flutes. They look like they're going up, right? Right? Okay, that is an upcut. That means as it's turning, it's lifting the material up as it's cutting. So if you cut plywood with an upcut tool, guess what? It's going to be ragged on the top side. I mean, it's going to be ragged, real ragged. Because the flutes are lifting the material up. As it's turning, the flutes are lifting the material up and you'll get fuzz. Now, a down cut will go the opposite way. You see it? If I had a down cut in my hand and I was turning it, let's see if I can get a better picture here. And I was turning it, a down cut, you would be seeing it go downwards. Okay? Now, with that kind of motion, as you're cutting, guess what? It will be shaving off all these edges, okay, instead of ripping them up. So that's kind of the difference between an upcut and a down cut. One, your flutes will be going upward in an upcut, and with a down cut, they're the opposite, and they'll be going downwards. Okay? So that's the difference between a upcut and a down cut. Now, straight cut. Okay. Straight cut. Let's find, I'm going to find you a straight cut here. And this is a straight cut. You see how the flutes there are completely straight. The cutting edge is straight. So, what's this tool used for? Well, guess what? Straight cuts are used for acrylics and plastics. These are the best ones for acrylic. And the best, actually, the absolute best ones are for acrylic are a single flute. This is a double flute. This is a double flute. It has 2 flutes on it. Okay? And this is a straight cut. And that one is to be used on acrylics or other plastics. And you're going to find all kind of tools. I mean, believe it or not, this here is a straight cut. It is tiny, 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 tiny. Straight cut. Now, there are other different tools that you can get on the market. Now, here, this one here is basically a one flute cutting tool. Great for acrylics. Now, there's for larger machines. I mean, there's all different kind of tools that you can get for other machines. I mean, for different tools that you can get for different purposes. For example, this here is a ball nose. Let me see if I can just get a little bit better picture of that. So this is a ball nose. Now, and you get those in different sizes, and they have different shapes. But the thing is, when it comes to cutting tools, guess what? You get exactly what you pay for. Okay? Now, these cutting tools here that come with most of the machines, or you buy them or from Saint Smart, or you can buy them from any other different place. These are made in China. Now, this set here with the different sizes, okay? I can tell you right now that the sizes vary from the smallest, which is 0.8 millimeters, up to 1/8 of an inch, which is 3.175 millimeters. Now, these tools here, a little bit about these tools here. The first thing I can say is this. Let me just move around here a second. There. The first thing I can say about these tools here, they are great tools for beginners to learn to use their machine. When you're learning to use your machine, guess what? Breaking a tool is going to be part of your daily life. I mean, it's going to be a part of CNC, your CNC experience. Breaking tools. Guess what? It shows that you're pushing your machine. If you do not break a tool, guess what? You have not learned anything about CNC. Okay? You will never know how far you can push a tool until you break one. That's true. I'm serious. I'm just going to give you a little example of years. I'm talking way back when I was an apprentice learning CNC. Okay. And after I learned how to run the machine and everything, and actually I was running the machine by myself during the second shift at work. And we had all kinds of jobs that we ran on that machine. But at this particular time, we were running a series of parts that they were all the same. And we had a jig where we put 10 parts in, clamped them down, started up, and it would mill them all out and everything. And so we were just making those. We had to make several hundred of them. And my boss come in, and he's standing there and he's watching the machine run. And he said, Paul, he said, we're not making any money. Yeah, I didn't understand what he meant. I said, what do you mean? No, he says, you're running it way too slow. He said, we're not making any money at all. He said, and I told him, I said, well, I jacked up the feed override. I said, I jacked up the feed rate, and I says, I don't want to break anything. And the boss told me, he said, this is his words. He said, I'm going to teach you how to make money. He said, he says, and the machine was running. He said, what I want you to do, he says, go over to the machine, and he says, and grab the feed override. And he said, what I want you to do is I want you to increase the feed rate, increase it, until it says bang. He says, then back it off a little bit. Yep, that's exactly what he said. He wanted me to bring the feed rate up so high that it would literally break the tool. And I did. I cranked it up, and it said bang. He said, now back it off just a little bit. He said, now you are going to know. Now you look there at what the feed rate is, you know now how much that tool there can take. He said, now put a new tool in. He said, okay. He said, that lesson there just cost us $50. He said, but the time that you are going to be decreasing on our runtime, we're going to make $300. So that's what I mean about breaking tools. It is not, now I'm going to repeat, it is not a shame to break a tool. But what is a shame? What is a shame is when you have a brand new $50 tool. Okay? You have a brand new $50 tool, and you put that in your machine and break it. That's no fun at all. Let me tell you, I'm going to be dead serious with you. That is not, I mean, like putting in a $50 tool and you hit carve and it starts moving and it goes right into the clamp. That is an amateur fault. That is a fault. That is something that you should have done with these cheapo tools. These cheapo tools are great for learning. I'm going to tell you a little bit more about tools. If I'm running this an 1/8" tool, this exact type of 1/8" tool. Now, this here is it's almost like a grinding tool. It really doesn't have flutes like you would think of cutting, like the cutting edges. They're more like, it's more like a grinding tool. Okay. Now, if I'm running this on my machine and I am milling out, let's say some cedar wood. Cedar cuts really nice. Excuse me. Now, I'd be running one of those tools, probably about 8,000 RPMs, 7,000 RPMs, something like that. And the feed rate is what really matters. Now, probably be running that tool at about 200 on a standard 3018 with a standard spindle motor. Okay. I would say that I would run it around 250 millimeters per minute. Okay. That tool there. Now, I'm going to show you another tool here that I have. And I was doing a 3D cut. Okay. And I bought a new tool for that. And it's a tapered tool. All right. And here it is here. It is a ball nose taper with a 1/16" ball at the end. Okay. Now, $50 for one tool. These tools here are $15 for 10. That is $1.50 a tool. Okay? That's $1.50 a tool. In other words, they are garbage. They are for beginners to learn to break things. Okay? These are, they work. Like I said, they'll work. But your feed rate's going to be low and your cut will be, well, come see, come saw. Okay? You start investing. Instead of $1.50 tools, go up to between $30 and $50 tools. Guess what? These tools here, first of all, they last hundreds of times longer. These tools wear out so quick that you can almost say that after 2 projects, you can throw the tool away. Okay? Because they don't stay sharp long. These here, this tool here, I ran it on that 3D that 3D part that I was cutting out. And this tool is still as sharp as a razor blade on the edge. And as a matter of fact, when you're doing, now this is really important, and I'm not saying it to waste my breath. I'm saying it because I've done it. Okay? One thing you never do. You know how when you have your tool in your collet, okay? Your tool is in your collet. Never, never grab a tool and try to pull it out of that collet. Because if your hand slips on an expensive tool, those flutes are going to cut into your fingers just like razor blades. And I'm telling you this because I've done it. Do not ever try to handle a tool by the flutes when you're putting it in or out of the collet. Okay? If you have to, use a paper towel. You wrap something around it because they will cut you bad. Okay? An expensive tool is as sharp as a razor blade, basically. All right? So, more about tools. This tool here that I just showed you, okay? $50. Now, remember I told you that cutting on cedar wood, I was cutting with a cheapo tool, an 1/8" cheapo tool. I was cutting at 250 millimeters a minute. Okay? And that is at 0.3 millimeters depth per cut. Okay? With this tool here, this tapered tool here, doing 3D, I was running my machine at 650 millimeters a minute at 0.4. 0.4 millimeter depth per pass. Okay? Tools are the heart of your machine. And like I said, your machine will never be better than the tool you have in it. Okay? Some more thing about tools. Now, for you people that have the standard 3018 with the standard spindle, okay? You're going to have a little bit of problem. You're going to have problems because you do not have RPM control on your machine. All right? Now, on my machine, let me just put this over here. I just got to move a little bit here. Okay, on my machine, you see the size of my spindle here, okay? And here I have, right here I have my rheostat. And here, this is where I adjust my RPMs. Okay? Now, I'm going to tell you the thing about I'm going to tell you the thing about RPM control. With a standard 3018 and that little spindle motor that's in there, it does 9,000 RPMs. Now, 9,000 RPMs are way too high for everything. Really. The only thing that they're good that it's really good for, believe it or not, are these here. And I'm sure you've seen these here with the ones with a rubber cap. They are called engraving tools. Now these tools here, they're called engraving tools because they're only for engraving. They They are not for cutting out a pocket. They are not for, these here are for very shallow cuts. I'm talking a cut under 1.5 millimeters. These tools should never, 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 never be used deeper than 1.7 millimeters. Never. They should never be used deeper than that. They should never be used for clearing out a pocket. These tools here are for very, very fine lines. Okay, very shallow, very fine lines. For example, if you wanted to cut out, a an acrylic, engraving on acrylic, okay, this is the tool to use. And this tool, you can run it with your 9,000 RPM spindle motor, and you can engrave on acrylic. Do not waste your time or waste your tools trying to cut out anything or cut through acrylic with any of these tools here. If you try to cut acrylic with these tools here, what happens is your tool comes down into your material, okay, at 9,000 RPMs. It starts moving along. By the time it's gotten 2 inches, it's already melted the plastic. The acrylic is already melted around the tool. It's not cutting anymore. And guess what? Your feed rate keeps going. So if your machine keeps going and your tool ain't cutting anymore, tick. Yep, that little noise, tick. And you broke your tool. Okay? Okay, now, when it comes to tools, like I said, each tool has a specific purpose. And they are made specifically to do a specific job. And it's your job to learn what they do. Well, okay. I'm here to help you. All right. Now, I like to experiment a lot of different things. Try different stuff, you know. I like to see what my machine is capable of. And so back to acrylic, and back to the standard 9,000 RPM spindle motor on the 3018. 9,000 RPMs is really, really high. Okay? It doesn't mean it doesn't work like this, that, since I just bought a new spindle motor and it does 20,000 RPMs. Useless. I mean, really, really. The only time that you want to use really high RPMs are basically milling aluminum. Okay? With that big spindle motor that I just showed you, this one here, with that big spindle motor here, I can tell you this. If I'm cutting wood, okay? If I'm cutting wood, doesn't matter if it's plywood or whatever, you know, if I'm cutting plywood, I'm going to be using a down cut. And depending on the size of my letters or whatever my object, that's where I determine what tools I'm going to use, tool or tools. So if I'm going to use a single tool or a two tool cut with a roughing and a detail tool, when I'm cutting on my machine, normally I'm running about 6,000 RPMs. Really. Because in today's CNC world, cutting tools, they are designed to be cutting all the time. Okay? They do not want to be what we call scrubbing. Scrubbing means there's two things that really kill a tool. I mean, it will dull it really quick. Okay? One thing is scrubbing, and the other thing is chatter. Now, I know most of you people know what chatter is. Okay? Chatter is when you are running your machine at too high of feed rate and you hear your machine start going and it's basically jumping, hopping. Okay? Not good. Not good at all. Okay? Bad choice. All right? When a tool is chattering, I give that tool 10 minutes and you can throw it in the garbage. Okay? Yep. You can throw it in the garbage. Now, the other end of the spectrum is where your feed rate is too low and you're running that tool at 9,000 RPMs and you're just chugging along really slow. You're not doing nothing except producing very, very, very fine dust. And if you are doing that, if your machine is producing very fine dust, you're doing it wrong. You're doing it wrong. What you want coming off of your piece of wood are little chips. That means that each flute, as it's going over, it is cutting into the material and actually creating chips. But if your feed rate is too slow and your RPMs are 9,000 RPMs, you're not doing nothing except scrubbing it and you're dulling it. Now, there's one thing I want to mention right now before I forget it. Because yes, I forget a lot. Okay? What was it I was going to tell you? I really did forget. I really did forget. About cutting tools. Oh yes. This is a biggie. This is a biggie. And I'm going to give a big shout out to all you hoarders. Okay? All you hoarders. Whatever you do not hoard old tools. Rule number one with CNC tooling. Do not hoard old tools. And I'm going to tell you from experience, it will, not a question of if, but it will come back to bite you. Okay? If you take an old wore out tool and you have it up with the rest of your tools, and you buy an expensive piece of wood, exotic wood that you're going to make a carving, and you grab that old tool by mistake, you could ruin a $50 piece of wood. Yeah, that's simple. Okay? Do not hoard old tools. Now, one thing I do sometimes, and I got to kind of dig it out here so I can show it to you. And let me see if I can get it here. Now, I'll take an old tool and I'll put it on my lathe. And what I do is grind it down right into a tip. And I can use this. I can use this to locate my 0 point, and I can actually go down and make a little dot, make a tiny impression on my piece of wood. And it's like a universal 0 point, zero setter point thing. That's all. And you can use it, for cleaning your fingernails or whatever. But if they're wore out, don't keep them with your cutting tools. Okay? Really, bad idea. Bad idea. I want to mention another thing, and I notice it a lot. Okay? Safety. Safety with these machines. And most people think, oh well, I have this desktop CNC toy hobby machine. Okay? But I'm going to tell you something. You put a tool in that cheap spindle that comes with the machines. All right. Now, I say cheap spindle. The spindles that come with the 3018 machines, they are cheap spindles. They literally, if you were to replace an original spindle, which I don't even think I've ever heard of anybody doing it. As soon as their spindle starts making noise, wearing out or anything, because they do wear out real quick. Because guess what? They do not even have bearings in them. No, the original 3018 spindle does not have bearings in it. It has brass bushings. Okay? And the thing about it is that the at 9,000 RPMs, they wear out real quick. And especially if you are pushing your machine hard. That if you're really running it hard and you're pushing your machine hard, those spindle motors, they'll last like 3 months, 4 months, 5 months, depending on how often you use your machine or whatever. But then it is upgrade time. Yes. Now, upgrades. The biggest thing you want, the biggest thing, if you want to expand the possibilities of your 3018 and what you can do with it. Now, I'm talking about what materials you can work with, what you can cut out, what you can engrave. Now, remember I showed you these here? These here. These were the rubber cap, the engraving tools. Have you ever noticed that they're actually called 3018 engraving machines? CNC engraving machines? You know why? Because basically with that 9,000 RPM spindle, that's what it's best for. Engraving. That's it. That is it. Really, really. All these other tools, 9,000 RPMs is way too high for them. So you're scrubbing them. You dull them out. And a $1.50 tool doesn't last long running it at 9,000 RPM, scrubbing it. So the first thing most people do, and it's the first thing I would recommend if you are thinking about doing anything with your machine as far as upgrades, think about your spindle. Remember what I said now about cutting tools. Cutting tools are the heart of your machine. Now, what could be better than be able to control your tool speed with the RPM control? Okay? By doing that, right now, with a standard 3018 machine, you have your feed rate, and the most important thing of all is your feed override. I mean, I'm serious. If you're not using your feed override on easel, then you have missed the boat. Really, you have missed the boat. Then you ought to sit down and re-watch my marathon videos, okay? Because you're doing it wrong, all right? Now, back to upgrades. People ask me, hey, I want to do an upgrade on my machine. What would you recommend? Spindle. Control, spindle with RPM control. RPM control. And a spindle that is quality. Now, by quality, I'm not saying max RPMs. 20,000 RPMs. When somebody tells me, I just got a brand new spindle motor, and it does 20,000 RPMs. Well, the first thing I think of, 20,000 RPMs. That's about 14,000 wasted. Because if you're going to be carving in wood and stuff like that, the best cutting RPMs are around, like I said, I use depending on the wood type and what cutting tool I'm using, I'll be running between, just to give you a little bit of a idea, between 5,000 and 7,000 RPMs. That's it. Really. Cutting acrylic. Down to about 3,000. Down to about 3,000 RPMs. Yepers. Very slow RPMs. Cutting acrylic with a single flute tool. Okay? So, to kind of sum it up, like I mentioned, cutting tools are the heart of your machine. Now, what runs your cutting tools is your spindle motor. That is basically, really, to be honest with you, that is the heart of your machine. Your tools are just a medium. But so, if you are planning or thinking about doing an upgrade on your machine, don't worry about increasing the bed size. No. Change out your spindle first. Okay? Because I'm going to tell you, you put a 500 or a 300 watt spindle on your machine, with RPM control, you have changed your machine from this thing to this thing. Really. And you're changing what you can do with it from this up to that. Okay? RPM control. Oh my God. I can't stress it enough. RPM control and feed override. Those two go hand in hand. They're like your two, like bread and butter or peanut butter and jelly, okay? They are just like your two legs, okay? That you're walking on. That's how important those two are, all right? Now, and like I said, you should be, when you're carving, that first half hour, 45 minutes, maybe even if you're a beginner, you should be on your feed override and your RPMs. You should be there adjusting both of them. You adjust your feed rate up a little bit, and you listen to your machine. And then you increase your RPMs a little bit, and you decrease them, and you listen, and you increase it, and you listen. The only way you are going to learn to use your machine like a seasoned CNC operator is by listening to what it's telling you. Your machine will tell you, excuse me, your machine will tell you if you are using the wrong tool. It will tell you if you're using the wrong feed rate. It will tell you if you're using the wrong RPMs. Yeah, it will. But you have to learn to understand its language. And its language is sounds. When I adjust my machine, I want to hear that thing humming like a Singer sewing machine. I want it humming. And I want beautiful little chips coming off that wood. Not dust. Okay? So, the biggest things about a 3018, a stock 3018, is you are limited to what you can do. Now, I know there's in my group, out of the 2,000 plus members, I'd say 40% of them have stock 3018s. And they show me their projects, and they do look good. They're beautiful, gorgeous. But once they upgrade to a bigger spindle and start investing money in real CNC tools, my God, I can see the difference. It's like night and day. It really is. It really is. There you get so much more out of using the correct cutting tools and using the correct RPMs and using the correct feed rates. Okay? And the only way you're going to learn that is by doing it, adjusting your feed rate feed override, and your RPMs during the first hour of your carving. Really, you should be sitting there tapping on the plus on your feed override. Tap on it, you listen to your machine. Tap a little bit more, listen to your machine. Tap up a little bit more, listen to your machine. your machine starts sounding like it's liking it. It's smoothing it out. It's just sounding nice. You're getting nice little chips out of the wood. And then what do you do then? Jack up the RPMs a little bit. And then play with your feed override again and listen. And listen. I'm going to tell you that there is absolutely no difference between milling on a CNC machine, cutting, burning with a laser, or 3D printing. There is absolutely no difference between those three and an old style black and white camera. Taking pictures with an old style black and white camera. Because when you have a old black and white camera, how do you get a perfect picture? A perfect old style black and white picture. Okay, I'm going to tell you. You have to have the perfect exposure. Now, in the camera language, the perfect exposure is the perfect combination of light and time. If it's very bright, you use a short time. If it's very dim, you'll use a long time. But you have to have the correct balance to get a perfect picture. Well, guess what? There is no difference between a CNC carving machine or router or a 3D printer or a laser machine. A laser machine is easy to explain in the exact same way. On the old camera, you have light and you have time. On a 3D printer, you have laser intensity and feed rate, because it is the exposure time. The time that laser is actually in that area burning the wood. It's your exposure time. So you have to have that perfect balance on a laser machine to get a good picture. Like this is, well, that's a crummy picture, but just to show you, you know? Carving, there's no difference. You have RPMs and you have feed rate. Okay? Okay, you have other little variables. You have your depth per pass. Okay? You have your cutting tool. Is it a $1.50 cutting tool? Or is it a $50 cutting tool? So, on my YouTube channel, guys, I'm going to try to keep these to 1 hour. Okay? And so I'd like to thank Steve Morigi and Steve Coey. Good afternoon, man. Good evening. Good evening. And Jim Weber, I'm glad you found it, man. Mark Leonard, breaking stuff is a milestone. Oops, too much. Let's dial that setting back. Yep. Crank it up with these tools here. With these tools. Crank it up till it says bang. Back it off a little bit. Put a new tool in. You save some time. Okay? And Pete Bernard, nice to see you. I'm glad you guys can make it, man. Glad you guys can make it. So this video will be in my Grupo, in my YouTube channel, okay? And thank you all very, very much for joining in. And we'll be seeing you guys. And I hope I helped you out a little bit with tools, feeds, speeds, all that. Okay? Remember, it's all about getting the correct exposure. Okay? Have a good evening, everybody. I'll see you next Monday. If I am going to do anything prior to that, I will put it in the group. Okay? And I don't know why Facebook has cut me out of live videos. I'm not in Facebook jail or anything, but they won't let me do live videos. I guess I may have used up my quota. I don't know. But I know what they can do. I got YouTube. Have a good one, guys. Everybody, girls, everybody. Bye.